But welcome glad to have you. My name is Daniel. I am with Tynker, and I'm really excited to kind of share. I've been with Tynker for now 5 years, and always very excited to share where we're going with computer science and STEM. This is all about kind of taking the leap with computer science and STEM. I'm so glad that Illinois has finally jumped onto the standards bandwagon to see that we're making some real strides with computer science in Illinois. It's taken a little bit of time, but I'm glad to see what we're doing that. I'm a longtime educator here in Illinois. I've been a computer science teacher, STEM director, STEM coordinator person. I've had a lot of different hats. And in my last school in Palatine, I really, was trying to make the move to go from kind of computer science engagement, where we're all just kind of playing with computer science and coding, to actually seeing results. And that's where I kind of stumbled onto Tynker, and where I really started to see some great benefits to this platform and this coursework. So that's kind of where I'm coming from a little bit when I talk about Tynker, when I talk about this coursework, and I'll break things open so you can see kind of everything that goes behind the curtain, so to speak. But our agenda today, we're going to kind of talk a little bit just about what is Tynker. Maybe you've tried or played around with Tynker, in the hour of code exercises. We were partnering with NASA earlier this year, end of last year, and did a lot of cool NASA projects. So maybe you've seen a little bit of that. But I do want to talk about Tynker just as a path to mastery. So we have to start thinking about computer science as kind of not just a place where students are engaged and can have fun, but also can start really building skills so that by the time they get into high school, they're ready for, advanced computer science, or maybe they want to try an art class and combine art with computer science, a lot of different things. So I want to show you how Tynker is ready out of the box. And this is one of the things that really helped me as a teacher, where I was able to, as a STEM coordinator, work with my teachers and then just see them adopt and use Tynker with their classes after just a couple of weeks. It wasn't something everybody had to do, and didn't have to go to computer science camp all summer to learn how to use Tynker with their students. There's some great STEM integration pieces too. I want to make sure you get a chance to see those and see how they all coordinate with core curriculum. And then think of computer science this way as more of a systemic solution to your school, not just to a classroom, but your school and perhaps your district. Tynker can work for all three things. So let's start with the what is Tynker. And if you have questions as you go along, I don't know if there's a Q&A or that you are able to put things into the chat, but I'll at least kind of, take a look at that. So I can maybe address things along the way, or we can wait to the end. It's up to you. But three big things here on this page, really, that I want to highlight. The STEM piece I've already kind of mentioned is really important. And that, what if you were able to not just, do computer science or do coding with your kids, but also you were able to integrate that into social studies, science, math, and English. This would be a great opportunity, a huge window for all of you to collaborate with your core classes, your core subject areas. Really helps, I think, in middle school a lot, because that's when the minutes start tightening up. But that was a big piece for me because I've always been kind of an integrator at heart. The other piece to Tynker, when we were kind of done with kind of just engaging with hour of code, we were ready for comprehensive curriculum. So Tynker is now 1,000 hours of coding from pre-K all the way to high school. So, and it's like a complete path. So you'll see that. So, and then of course you've got block coding options, you have text coding, now you have icon-based coding in pre-K, a lot of different options that kind of build all the way through that path. And then great little other pieces like automatic assessments, classroom management, professional development. Our training is really awesome, and you'll love what you see from our PD. Oh, there we go. So that's three things I want to just point out as like a system-wide solution for schools. When it comes to teachers, you've got all of your lesson plans. We've put everything together. Basically, you've got presentations, you've got lesson plans, you have everything you need right there. For schools, you have an administrator of a school administrator that can track success from every teacher in a school. They can connect with parents and send home, parent progress reports. There's some connection there that's really helpful. And then as a district, you're also seeing district-wide metrics. So if you want to adopt Tynker as a district, you can see a bird's eye view of every school, every teacher, every location, which is really helpful because then you know how to help them if you need to, offer some more PD or assistance to them. So it's really helpful, and I'll make sure to show you those as well. So Tynker, this is our mission, to empower kids to become makers. And you see it every day when students are going through the Tynker lessons. They're building all these projects. Every day you're seeing projects, and they're making stuff. We integrate with hardware like microbit and drones and spheros. And if you're a Minecraft school, you can actually code with Tynker in Minecraft. You can use your camera for augmented reality. Students can kind of code themselves into their projects. And then of course you've got all these 1,000 hours of coding coursework as well. We partnered with code.org kind of since the beginning. So we have been in the hands of 60 million students all around the world over the last 9-10 years. So a lot of students and schools. I think it's actually 90,000, 100,000 schools across the world right now. Just a sampling of some of the schools that are the bigger districts that we've worked with: Chicago Public Schools and Barrington Public Schools. I know we've got a number of larger districts here in Illinois. So I want to pause here. I just wanted to, this is kind of just a way to break down how we've got this path. And so now we've got the pre-reader path, which is icon based. So you have students that are able to, basically tap. It's all audio. It's on an iPad. It's on a touch-based device. Then we move into block coding with kind of the K5, 6, 7 with block coding. Transition to text-based coding, JavaScript, Swift, Python, web development. And then you get into high school. You've got a lot more opportunities with processing.py and Java and data science. And there's just a great opportunity there all the way through, and everything's connected. So we'll start here by just kind of opening up Tynker Junior, and just keep in mind, but if you all stay with me, I'm going to make sure that by the end of today's webinar, you all get a link to try Tynker, whether you want to request Tynker or you want to just give it a trial. I want to make sure you all have links for those things. So stick with me for a few minutes. But this is Tynker Junior, and I love it because it's audio based. Hopefully you can hear that. And this has 10 experiences. We are now on Android as well. And that means if you have a Chromebook and you have the Google Play Store, you can actually access Tynker Junior through a Chromebook or iPad. But basically, we're teaching pre-readers using icons and images and then audio only. And so it's just a total, all of the great computer science skills are being taught here: sequencing, pattern recognition, conditions, and loops. And it's amazing when you can see, 4 or 5-year-olds working their way through building these their persistence, their grit, their growth mindset, as you will see when students use Tynker and go through computer science lessons. They're gonna have to do them more than once. So this is just one example, but a lot of fun and a great experience for students. It's all self-guided, so it kind of follows Tynker's model of self-guided scaffolded curriculum. And you'll see that as we move on to block coding and text coding as well, that students can do this anywhere. They can go and do it from any, laptop, or they can do it from home. It's all web-based. So you have 1,000 hours, you've got pre-reader courses, you've got block coding courses. Then you're getting the text coding courses. High school now, we've got data science. There's an art course for high school. Hopefully I'm going to get a moment to show you that as well. And then just hundreds of project templates and that you can access and your students can explore. So there's never, and students are never done when they're using Tynker. I do always get, students asking me like, hey, or I finished my lesson. Oh, did you lose my screen? Oh, how did that happen? Are we back?
We gotcha. Yep.
Okay. All right. Sorry, I'm back. Thank you for pointing that out. I'm like, where's my little, that just seemed to pop out. But all right, I'm just gonna, how long did you miss my screen for? That's the question. All right, we're good. That was not, all right. Well, I'm gonna back up 2 slides just for all of you because I want you to see the Tynker Junior experience. So I'm just gonna back up right here so you can see this icon-based experience. So
Tynker Junior.
There you go. This is all touch-based and it's all audio. So if you can hear the voiceover through that, it's just a great experience for students. I love it. And there's 10 experiences, 5 kind of standard courses, but then there's 5 studios as well that allow students to just explore.
Which coins should we collect first?
Build different projects like greeting cards and audio projects. I won't stick on this too much longer because I know you did have already heard me talk about it, but I did want you to see it again. But once you get past Tynker Junior, then you move on to the block coding courses. There's hundreds of hours of code opportunities. I mean, there's just great many opportunities there. There's our text coding courses, DIY projects. There's STEM lessons, which are directly go directly into your core curriculum. And then there's electives like augmented reality, Legos, microbit, and drones. So there's never, students are never done when they're done with Tynker. They may be done with a lesson, but there's always an opportunity for them to continue learning. So here you have the pre-reader courses. This is just a snapshot of our entire curriculum kind of in one slide. So I wanted to make sure that you saw this. Basically from pre-reader all the way to high school, we just added Java 101. And of course, we have the high school AP Computer Science. So if you're starting to look at those standards and thinking it's time for you to, integrate computer science into the high school, then you have this great opportunity. I love my cat. I'm glad they came to visit. But you have this great opportunity to do that with your students in high school. And there's a great intro course as well, which I like because it's an art course. So you have Intro to CS with Art, which is a processing course. So that is a great way to just introduce students to computer science who've never would think of doing a coding course. So here's just basically a kind of a snapshot of our core coding coursework before we get into high school. You've got the pre-reader, you've got some puzzle-based courses, 1A, 1B, and then you've got 101, 102. They get into project-based, which are basically semester-long type of courses. I'm going to open that up here for you in a sec so you can see what that looks like. And then you get into, the more the middle grades, JavaScript, Python, web development, and advanced Python. So let's kind of crack open kind of the K-5 and middle coursework so you can see what that looks like. I'm going to go to my my classes here so you can kind of see what my overview looks like. All right, thanks, Valerie. So here's my overview. Every class kind of has an overview so I can see a kind of nice snapshot of where everybody is in my class. So I get a little bit of data that I can see what do they do? What do they do in their previous lesson? How much activity do they have? How many projects did they do? And where are they along concepts mastery? So this has been really nice. It's actionable. I'll go back to my class here so you can see I don't have a lot done in this particular class, but if I need to add a lesson or something like that, I can go to my lessons page and I can assign a course or a STEM lesson. So let me go to assign a course. And now I have all these great opportunities. I've got my, my Tynker Junior. And so I can assign that. My students, if it hasn't been assigned and they log into Tynker Junior, they're not going to have access. But so that will kind of unlock things for them. There's a couple free courses here, 100 and 300. So if you just want to give your students a starter course, you can start with 100 or 300. If you want to start them off on just a puzzle-based experience, which doesn't have any projects, it just kind of gets them practicing. You've got Space Cadet and Dragon Spells 1A and 1B here. And these are all, this is a puzzle-based experience here. And there's no projects. It's just basically kind of takes them through step-by-step skill practice here. Once we get into the 101s, you start to see project-based coursework. So now we've got 101, 102, 201, 202. And here we're going to have lesson plans. Let me go ahead and open that up for you. What you get with every course is completed lesson plans. So you've got about 15 to 17 lessons here. You've got, which could be, if you break it out up into a semester, you could do about a lesson per week if that's your plan. But everything is scaffolded. So when students start, they're going to start kind of in the beginning here and build their way up the ladder until they get to kind of their final project and they have a quiz. So you've got formative and summative assessment for them there. These lesson plans are great because now I don't have to spend, all my hours up to the wee hours in the morning creating lesson plans. We've done that all for you. And again, that's, I think, a really nice piece. This is what makes it possible to just put this into a teacher's hand, like I said, out of the box, and have them succeed with it, because they don't have to spend all this time doing that lesson planning. You've got answer keys, which you are going to want to need. You're going to want to have to a lot of puzzles in here that you're probably not going to be able to memorize, but everything there, your answer keys. And then you have something great, which is your class presentations, which is basically if you want to run this lesson live, we've done all your slideshows for you. So you've got a badge, you've got today's kind of like, I can statement there, and then the Tynker blocks, the vocabulary, everything you need for that lesson. And then you can run that live and students can be off and running. So let me open up the first project here so you can kind of get an idea of what that looks like. So if you've done Tynker, you've seen the Tynker workshop. It looks like this. And on the left side, you have what is a tutorial here. So you'll see a little model of what a sample project looks like. And then students can close that up and they can start coding their own project. They'll go right to the next step and go step by step with these instructions. So this is kind of just, if they've never coded before, this is the first time they've ever used the Tynker workshop, it really helps them along and they can actually pull those blocks right in from the tutorial and start coding. So this works really well. They can close that tutorial, they can open that back up if they want to grab more code blocks back here from the code library, they can do that. And then the top here, this is what we call the stage. And then the bottom are where this bottom right is where we add our actors who are on the stage. So I can add actors. And what's cool here is that I've got hundreds of options for adding new actors, new characters. I've got a media library that's just so vast. I can add, based on people, animals, I can add a whole bunch of different things here and add those as characters in my little coded story here. I've got something called a backpack that allows me to save code. So if I was, I think it's a really good practice for students as a computer science practice to save your code. So you can quickly bring it back, or you can save other actors and actually bring those into your project if you had them in a different project. So now I've got my baseball, I've got my squid here. I might need some animation code for my squid, and I can drop that into my code editor here and start adding some elements to my project here. So that's it's just a really, really seamless experience. And again, students don't have to recreate the wheel every time they start a project. They're going to be building on this vast library of code that they have been building over time. So it's a really nice piece there. This is the Tynker workshop. So keep in mind, just a review, you've got all your lesson plans, you've got, just hundreds of projects and opportunities for project templates here in the projects database. So once students are done with a lesson, they can go and they can just start building on that. Let's say they went through the Tynker workshop, then they can start building an animation project, off of the skills that they just learned. So there's a lot of opportunity here for them to then further their skills. If they just want to explore and want to see, what is JavaScript and what does Python look like? There's a bunch of Python and JavaScript templates that they can start just to start playing around with with all of this. So that is a lot of opportunity there for creativity. There's a whole game developer aspect to Tynker as well. So if they create a project, you can go here and you can start creating some games, game elements, multi-level game projects there. There's a lot of game opportunities here in the Tynker project area. Yes, they can use their skills. It's really designed, they should be making, the more projects they make, their mastery level goes directly in line with that. So you'll see that, the more time, the more projects they amass, that when you go to their gradebook and you see their mastery progress, you're like, oh, I see, they're spending a lot more time in there and they're building on those skills. So just a lot of opportunity for you as a teacher and students to keep making. So the STEM coding course is a big deal for me, and I think it should be for you. This is a great opportunity, to, again, get STEM out of its little bubble. Sometimes it can be put in. Sometimes, we have that coding teacher or that STEM teacher, and they're, designed to do this, but we can make this happen in science and math and social studies and English. I actually did this with my last school. I had an opportunity to work with my social studies teacher. And so we had this great opportunity. My social studies teacher did not know how to use Tynker. The kids did. So we just took the social studies teacher's guidance as to what they wanted to see in a project, and then we built a timeline, which is something all of my history teachers love to do. They love to make and create timelines. So you can do that in Tynker. There's timeline projects that we kind of remixed ourselves, and this was I think this was Black History Month, and we were doing some projects based along that. So that's the subject matter projects that you'll see there. And then this is another opportunity. So you've got English book reports, right? I know you're going to do book reports. This was a great opportunity here to collaborate with an English teacher and do something that I know that they're already going to be doing. We're just going to code it. So Tynker views computer science as a language. So it's a language that we can utilize in every class. It's a language we can use anywhere if we're allowed to. So as long as students have the core skills of that language, we can apply it in many, many, many different ways. So this is just another example. Again, I think it's very accessible to the kind of things that we do in school all the time. If you take a look at the coursework here, you do get to see there's so many opportunities here with life science, English. Obviously science is, seems natural. There's 3 different science options here because you've got life science, physical science, and earth science. So coordinate with your science teacher and just say, hey, can we, I know you're going to be doing that plate tectonics lesson. Maybe we can work together and have the students show their mastery of that with Tynker here. So you've got a great opportunity. Here's an erosion project right there. So just so many opportunities here to open things up Again, just accessible to folks who may not be the quote unquote computer science teacher in the school as well. So there is a big game kind of aspect to once you start getting into the middle grades, there's an opportunity to kind of like take it into app development and game development. And so as you get into the middle grades, you start getting into like 301 and 302, we start getting like advanced block. And then we transition to JavaScript and Python and web development. So here in 301, I've opened that one up here. Again, you have what you're starting to see here are game elements. We're using a lot of the same skills that we've learned all the way back in preschool, with loops and conditions and a lot of these basic skills, but we're building on them in a more advanced way. And so I'll take a look here at my lesson plan here, again, scaffolded. So students are starting in one place and moving up to the quiz and the final project there. Great lesson plan for you here. Answer keys, class presentation, again, really nice there. Here, we're actually learning concept, but then we're actually kind of building along the way. So here we can help practice our night moves as they build these skills so they can kind of complete a final kind of game project here. So we want to animate the night using loops and conditions. So if I hit my left and right arrow, I can make my night move left and right. So that's great. And it kind of animates there. So just, again, these are game elements. Students are going to want, we're doing kind of a platform top-down type of game here. Just a great opportunity to build those skills. Because once you start getting into, once you've done that and you are starting to build, let's say, I go to the JavaScript course, when we're starting to really get into kind of, text coding here, we're taking those little game elements and we're moving them into the JavaScript language. And again, you see these same skills start again, loops, patterns, conditions, conditional loops, variables. They're coming at us again, but now they're in a higher order. And we're really using some skills that by this point, students should know over and over. Oh, I know what a loop is, and so they have a great opportunity here. Again, these are scaffolded. The way that JavaScript and Python is done is a little different. We're not using the Tynker workshop anymore. We have kind of almost a text book way to do these courses where we're running our code kind of like right inside a textbook, and then we can use our skill here, and basically it's like an interactive textbook that we can use and code directly inside the textbook, and then we get this chance to kind of apply it outside into an app or game. So and then we get a little quiz. So that is kind of the K-5 middle school block coding to text coding path. But it doesn't stop there, because we do then get the opportunity to then capture that success in a gradebook. So just keep in mind that Tynker is available on Tynker Junior, the Red app. Everything up to 201 is available on iPad. Once you get to 201, you have to kind of transition because you need a keyboard. So our 301, 302, JavaScript, Python, those are all keyboard based. But you're good into about 6th grade. Until you get to 7th grade, you're going to need to transition to a keyboard device. Although I have some people have told me that iOS, the new iOS, does allow you to use Tynker from the web if you have a keyboard on your iPad. So, but it's a little wonkier. So I wanted to make sure that you saw kind of how we collect mastery. We have something that is called a mastery gradebook. So as students are going through this, again, it's all self-guided. They can now, you as a teacher can go into your gradebook, and this is my kind of sample gradebook here. And I can see a snapshot of everything that's happening from free projects to, any of the templates that they've tried to all the lesson progress that they have here. I'll try zooming in a little. And so I've got any hour of code project. Let's say they went to the hour of code page. So this is one thing that I thought was kind of interesting. When I used to do hour of code, my students would kind of go to the hourofcode.com page, and then I would never see any of the final projects that they did because there was no way to save them or no way to track that. If they do an hour of code with Tynker and they log in, you can see all their hour of code projects. I just thought that was like a basic, like, that's cool. We have 2 courses that are called, or that are part of the Everyone Could Code initiative through Apple, which we started a couple years ago with them, and that's Space Cadet and Dragonspell. So those are available on the web and iPad, and they do have some ways that they kind of introduce students to Swift programming. So if you're doing one of those, you can toggle a button and you can see all the Swift code. It's kind of a very early way to introduce students to Swift. You have all my lesson progress here. I can click on any of these to see where my students are in a lesson, whether they've completed, whether they're in the middle or they haven't started. But again, it's a nice little heat map. Anything that I want to see a lot of green here. And this is just kind of basic quizzes. So as they're taking these quizzes, I can see and capture, any of their quiz data that's coming in. I can put that in my gradebook. Anything red is a red flag I need to see right there. And then green is complete. But again, I can see all those grades as well. Concepts mastery, that's my favorite. Like I said, this is the one thing that if I, as a teacher, I have gone to my administrators and I said, hey, you have to look at this, because in the past, maker, my maker class or my STEM program is always very process graded, right? How did you do on the process, which is great, but getting some real reliable data is something else. And we started using computer science as a way to kind of track the success of that program. And it's a great baseline for any STEM program because you get real data. So you can see here, we've got basic skills that we're going to see over and over again as they go from P101, P102, 201, all the way into high school. So yeah, no, this is really helpful. And just as a heat map, if I back off and I look at the green, everything in green is mastery. So my students, even after only a month or 2, are mastering some basic little skills like simple motion. And so then I can scroll over and it really starts to get a little bit, you can see I've got advanced text, advanced string handling, I've got some advanced skills going on over there. But yeah, this is just really helpful, and it's accountability. I think that's the big piece that's been really helpful. So yeah, data isn't bad. I like data. I like to know. I don't like to be lost, when it comes to how I'm, assessing achievement. I like having some baselines there. So that's the gradebook. I did want to just make sure you also see that that's kind of a great solution for teachers and for schools. On the district side of things, I have something called the, my district dashboard, and I have metrics where I can see from a bird's eye view all the success that my teachers, my students, and every location in a district is making. So I've got lines of code, assignments completed, that kind of thing. So it's really just super helpful. If I have a tech, group of, tech coaches, I can look at this and I can see who needs help, who needs more professional development. I can kind of sort all these things based on their concepts breakdown or how many assignments students have completed. And I can see that, maybe some of my schools need a little help. And so it's a really nice top-down kind of view for me to see that success. So I see we're okay on time, so that's good. So I do want to just show like one final piece, at least when it comes to this puzzle, and that's the high school piece. And I think this is a really important piece. And the reason it is because Imagine you are in high school and you're teaching computer science or you're teaching art and you want to get students interested in coding, but the word coding or computer science scares students. You have this is the high school coursework, by the way. So you've got a crossover from programming through 302 to block, and then we get into the JavaScripts and Python and advanced Python. There's something here called the Intro to Programming and Art, which is just amazing. So we worked with a professor out of Cal Poly who's art and design, basically they do this type of thing all the time. And so you can see this particular course is a great introduction to students who may not be interested in computer science, but it basically blends all the worlds of art and computer science together. And so this is basically a beginner course here as well, but I'll just take you on one of the units here. Let's take a look at colors and shapes, and we'll take a look at that lesson plan. Here you have all these great lessons for complex colors and shapes. Again, it follows the Tynker format where, every class is designed to be about, 50 minutes or so. And here, what we're going to be doing is learning about color space, hue, saturation, and brightness. But we get to do this in a way that's, integrates computer science, and it's just great. So we're talking about creating a logo, and there's a demonstration project here. I can view that code to see what that project looks like. And basically we're just kind of pulling, some JavaScript with a main file there and kind of running that code. So there's just, I could keep going on about this. There's a lab that's empty here. Now you can actually start building your project there, but there are just so many opportunities here. Origami, and we're really getting and integrating some great opportunities here for students who may be good artists, but kind of, again, maybe they fear the word computer science or don't know that if you're an artist in the 21st century, you really need to know code. You really, really do. It's going to be very important. And then you have, Java, you've got AP Computer Science Principles, and Data Science is another really exciting one that we're seeing a lot of interest from high schools as this great kind of extension. This one is a little bit shorter than the typical class, but they're going to be using like spreadsheet data and integrating that into, and building graphs with code. So here you start to see, again, a lot of great let's do some scatter plots, with processing here. So that is some, I just wanted to, open that up so you can see a little bit of the high school stuff. If you go on Twitter at all and just take a look at, Go Tynker on Twitter, you'll see a lot of great shares from people that are doing this actively with their students in their schools. But I do have a few minutes. If you have any questions, I do want to make sure that I get any of those answered. I can point you into some areas here if you haven't had a chance to see something. If you're interested in obviously PD hours, you should go to tynker.com/training, because we have a whole certification track, which I believe is free. So you've got if you just go to tynker.com/training, there's a little certification, and there's basically 3 webinars with a little bit of homework that you have to do to get level 1 certified, so you can be the Tynker guru at your school. Very helpful there. And then if you want to try Tynker, I give you 2 options here, basically. If you just want to get a quote, kind of see what it's like for your school. Great, Terry. We've done many of those. If you go to like the student data privacy website for Illinois, every other day I'm getting one of these agreements with the Exhibit E. So I don't know if you're doing yours separately of that, but that's been a great place for us. But thank you, SOPA compliant. But I am doing trials, but I'm also just, if some folks want to jump ahead to the line and take see what a quote looks like as well. I can do both if you like, but there's just some custom links there for you. Go Tynker/try Tynker for the trial, and then go Tynker/idea 10 off. I should probably put those in the link so that it makes it a little easier for you, but the QR code works amazingly as well. So thank you. SOPA compliant. That's a good question. Thank you, Terry. Any other questions about that as well? That's an important question. I know that comes up occasionally. When it comes, we do have a scope and sequence as well. And you should, if you just Tynker scope and sequence, which is here, everything is aligned to ISTE and CSTA standards. I'll put that in the chat to everybody. That's a great little extra resource there. But because I know that's another thing that you might want to be looking for. I know the Illinois standards were based off of the CSTA standards. There's tons of similarities. They're very, very similar. So you should look at at least for now, the CSTA standards on that scope document. But questions, thoughts, concerns? You want to see that QR code again? That's what you said? Okay. If you want to get 10% off, you can do that. If you want to try Tynker and just get a trial, I will be happy to provision a trial for you there. But I'm really excited and thankful that everybody came to today's webinar. And if I haven't shown you enough, I hope I did. Oh, there you go. And there's a link in the chat.
PD link is in the chat. Daniel, thank you so much. It's always amazing every time I sit through one of your webinars to see how powerful Tynker can be. There was a lot of chatting going on about the data.
Oh, yes.
As well. So, that in itself, I think, is just really something for everyone to be aware of, and how utilizing Tynker can be so very powerful in the work that we're doing. And one of the things that's been so important to us is kind of, I guess the terminology that we're using is demystifying or debunking computer science. So many of us feel, I don't know how to code. I'm not sure how to do this. But I think having this available and having that data available really helps educators see that it can be something that they integrate into the work that they're doing, and doesn't have to be something that you spend a lot of time on. You don't have to learn Java, I guess, is what I'm saying, to be successful.
No, not at all. I had my teachers, I remember my last school, and they were, some teachers who still were working on trying to figure out how to use Google Docs. Yeah. But I handed them Tynker and they were like, oh, I can do Tynker. I'm like, really? Yeah. Okay. So apparently Tynker, was easier than Google Docs. So I have that. So.
Well, Daniel, thank you again so much. For those of you that joined us, thank you. We will be following up with an email tomorrow that includes the recording for all those that were registered and attended. And again, the PDH link is in the chat, and feel free to reach out to us. Please continue to follow us on our Wednesday webinar series, as we have a lot of great things coming up. And again, a big focus on computer science. So big round of applause and thank you to Daniel, and thanks to all of you that joined us today.